Alright everybody, today we are going to learn 1.13 right triangle trig, and we are going to review a little bit of our SOHCAHTOA. We already learned that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now, the twist that we're going to add today is that we have to identify which sides are opposite, which sides are adjacent. The side that never, ever changes is the hypotenuse. The hypotenuse is always the side opposite the right triangle, and many of you remember it being always the longest side. What's going to change is where theta lies. If theta is up here in this angle, opposite then is across from it. Adjacent is right next to it. But if theta is down here in this corner, opposite now is over here and adjacent is over here. So that's really the only twist to this, is making sure you know where theta is. Okay? So, if I ask you to find the exact 6 trig functions, exact value of this triangle, and all I give you is this, first of all, what side are you missing? You're missing the hypotenuse, but we already know how to find the third side of a right triangle. A squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. Remember, A and B are the legs of the triangle. It doesn't matter if this is A and this is B, or this is A and this is B. What does matter is C is always the hypotenuse. So 5 squared is 25, 12 squared is 144. If we add these together and get 169, that doesn't make sense for this length to be 169. Remember, that is c squared, so when I square both sides, c is 13, which makes sense. It fits with 5 and 12, and it is also the longest side. Now, notice theta is up here. I would label the sides. It will make your life a lot easier. So theta is here, opposite is over here, adjacent is over here, and hypotenuse is always the longest side of the triangle. So now that I have that, I know that sine of theta, SOHCAHTOA, opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Cosecant is the reciprocal, so 13/12. Secant is the reciprocal, 13/5. And cotangent is the reciprocal, 5/12. So once we have things labeled, it's just a matter of filling everything in. Now, I want to remind you of your list of perfect squares. We have to remind ourselves how to simplify square roots. Perfect squares, remember, are 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. Of course, it keeps going on forever and ever, but that's as far as we're going to go. What I want to remind you of is, how do I simplify the square root of 8 without making it a decimal? Well, I have to take a look of my list of perfect squares and find the biggest number that goes into that evenly. This time it's a 4. So now I can rewrite this as the square root of 4 times the square root of 2. However, what is the square root of 4? It is 2. I do not know the square root of 2, so I leave it. And the square root of 8 simplifies into 2 square root of 2. Okay, let me do another one with you. How about, what does the square root of 32 simplify down to? Now, we could simplify this into the square root of 8 times the square root of 4, because 4 goes into there. But is there a bigger number that goes into the square root of 32 evenly? 16 does, and it's best if you pick the biggest square root. Square root of 16 is 4. I do not know the square root of 2, and so I end up here. Let's pretend I would have picked the square root of 8 times the square root of 4. Well, we would have gotten 2 square roots of 8. However, the square root of 8 can be broken down into 4 times 2 also. So now we would have had this square root of 2, or 2, this 2, and this square root of 2, or 4 square roots of 8. So it's much easier if you pick the biggest one. On your own, real quick, try the square root of 27. 27 breaks down into the square root of 9 times the square root of 3. We know the square root of 9 is 3, and that is the simplified version. So we're going to need this now as we continue to work forward in our examples. So let's find the exact value of the 6 trig functions of this triangle right here. So once again, what am I missing? I'm missing my hypotenuse. So a squared plus b squared equals c squared. 16 plus 64 gives me an 80. We do not want the decimal form of the square root of 80, but we want the simplified version in radical form. So if I look back at my list of perfect squares, I know that 16 divides evenly into 80 5 times, and the square root of 16 is 4, and I do not know the square root of 5, so this is my hypotenuse. Theta is over here, so this is my opposite side, and this is my adjacent side. And again, this is my hypotenuse. So now I'm ready to do SOHCAHTOA. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. Now, before I go on to the other 6, or the other 3, what's wrong with some of these? Well, they have radicals in the bottom, and there can be some simplifying. I'm going to start with tangent, that's the easiest. 8 divided by 4 is 2. Cosine, hopefully you can see 4 divided by 4, because they're both numbers, I can simplify them, is 1 over the square root of 5. However, we learned that you cannot have a radical on the bottom of a fraction. So I need to multiply both the top and the bottom by the square root of 5. 1 times the square root of 5 is the square root of 5. The square root of 5 times the square root of 5 is the square root of 25, which is 5. I cannot do anything with radicals and numbers, so I leave it. The sine, 8 divided by 4 is 2. Again, I cannot have the square root of 5 on the bottom. So I'm going to multiply the top and bottom by the square root of 5, and I get 2 square roots of 5 over the square root of 25, which is 5. 2/5 cannot simplify, so I am done. Now, here's the trick. When I go back to cosecant, if I flip this, I'm going to have to rationalize again. I'm going to go back to the original before I rationalize and flip that one instead. Now I don't have to rationalize. Same thing here. If I reciprocate this, I'm going to have to rationalize. If I go back to the original, I'm going to not have to rationalize, and I get the square root of 5 over 1. Tangent is 2, or 2 over 1, so cotangent is 1 over 2. Okay, let's keep going on. Now, if I asked you to sketch a triangle with knowing the sine of theta is 2/3, find the other 5 trig functions. Well, first of all, we can go ahead and sketch this triangle knowing that sine is 2/3, or in other words, sine is opposite over hypotenuse. So if I make, and this is always right triangle, this is right triangle trig, so there's always a right triangle. Again, you need to declare where your theta is. So if theta is here, opposite is here, hypotenuse is here. I still have to find my adjacent. So there's my opposite and my hypotenuse. This time, when I do a squared plus b squared equals c squared, I do not know b. So 2 squared is 4, 3 squared is 9, subtract 4 from both sides, and take the square root, and b is the square root of 5. So you're using the Pythagorean theorem quite a bit now too. Alright, so if sine is 2 over 3, cosine is adjacent over hypotenuse, and tangent is, and again this is my adjacent, opposite over adjacent. The cosecant is the reciprocal of sine, so 3 over 2. The secant is the reciprocal of cosine, and the cotangent is the reciprocal of tangent. Now, it's up to you when you want to do some rationalizing. Sine was already done. Cosine is done. Tangent, I have to multiply top and bottom by the square root of 5, and I have 2 square roots of 5 over 5. Cotangent is already done. Cosecant's already done. But the secant, I have to multiply top and bottom by the square root of 5. So we're using Pythagorean theorem, we're using right triangle trig, and we're using SOHCAHTOA. Okay? So on your own, sketch a triangle where cotangent of theta equals 2 and find the other trig functions. Alright, if cotangent is 2 over 1, we know that tangent is TOA, so cotangent is A over O. So here's theta, my adjacent is 2, my opposite is 1, A squared plus B squared equals C squared, and I get hypotenuse is the square root of 5. Sine is opposite over hypotenuse. Again, when we rationalize, we get the square root of 5 over 5. Cosine is 2 over the square root of 5, but when we rationalize, we get 2 square root of 5 over 5. Tangent is 1/2. Secant is 5, or 5 over 1. Secant is square root of 5 over 2. And cotangent is 2, like they told us before. Alright, go ahead and try the cosecant of 9 over 8. Remember, cosecant is the opposite of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Pause it and try to find your 6 trig functions. So if the hypotenuse is 9 and opposite is 8, we have to find our adjacent side by taking A squared plus B squared equals C squared, and I get the square root of 17. Sine is 8 over 9. Cosine is square root of 17 over 9. The tangent we have to rationalize, and we end up getting 8 square root of 17 over 17. Secant is 9 over 8. Cosecant, secant, when we rationalize, is 9 square root of 17 over 17, and cotangent is square root of 17 over 8. This is probably the most important part of trigonometry, understanding the relationships between sine, cosine, and tangent. Make sure you are labeling your sides. It will really give you, help not to make any errors. And also remember to rationalize square roots on the bottom.